Right, so welcome back to Form 3 Physics. This is week 3, and today we are going to be looking at random and systematic errors. Now, errors is a big study in science, and it's very important because in science, of course, there's a need to measure and do a lot of experimental work, and accuracy and precision are critically important if we are to achieve optimal results. So today our job is to learn about the two main classes of errors, which are random and systematic errors. So we'll start with the systematic error. As the name suggests, this error systematically happens. It happens every time we make a measurement. Usually this is because of the fact that the instrument may not be calibrated or set exactly to 0. So for example, if we have a measuring scale at home and the scale is set to maybe 0.5 pounds rather than starting at 0, every time we measure, the scale will read, the value that we get will read 0.5 pounds more. So the thing about systematic error is that we can predict it, and because we can predict it, we can completely eliminate systematic error. And that's one of the most important takeaways about systematic error, is that it can be completely predicted and completely eliminated as a result. A common systematic error is that of the zero error that I will address in the next video. The other class of error that we need to take a look at is that of the random error. Random errors occur, as the name suggests, at any time, and very often they cannot be predicted, and as a result of that cannot be eliminated. Random error very often is as a result of changes in environmental conditions, maybe changes in temperature, changes in the amount of light intensity, changes maybe in the air pressure that may affect an experiment. One of the critical things about random error is that it cannot at any point be eliminated. It can only be reduced. Right? So now I'm going to give you a little bit of an idea of how we go about reducing random error. Now, first of all, one of the best ways is to try to prevent it. And as a result, you would have to think about all the things that could go wrong in a possible experiment and try to put measures in place. However, in spite of that being done, random errors may plague experiments. And one of the best ways to reduce random error is to complete the experiment a number of times. So I'm going to show you how that is going to help. So let me just pan the camera over to the board so we can get an idea of what it is we're looking at. So if we were to look at the board, for example, we're looking at, as you can see the topic there, reducing random error. Let's say we were doing an experiment to find the value of gravity. Now CSEC accepts a value of 10 meters per second squared for gravity. So let's just say we did the experiment 5 times. Experiment numbers there 1 to 5. The first time it was done was way off, it was 8.7, and then subsequently the values of course would have been different, some getting close, some going a little further, and the closest of course being 9.96. However, if you look at, if we were able to find the average of these 5 values, you'd notice that we got the actual value of 10, right? So in this case, we were able to get rid of that random error by finding the average. Now, we may, this does not always happen. Sometimes we may get an average of, let's say, 10.01, which is still very, very close to the actual value of gravity. So this is one of the ways we can reduce random error. It is worthwhile to note we cannot eliminate, we can only reduce. And the best way to do this is to do the experiment a number of times and find the average. So I hope at the end of this video you understand just a little bit more about errors. Please read the summary, look at all the videos, and attempt the assignment. And I'll see you in the next video. Thank you.